I didn't get new stuff by choice, really, so.
Why don't you have an iPhone too?
Let's leave it at that. I go the other way. Which is...
How dare you?
It's fine.
Take it out of context. Huh?
It's fine. Yes, I have.
It doesn't swing that way, Billy.
Alright. So, we made it up through 7-2 for the test. 7-2 with like sine of s plus t and cosine of s minus t and all that kind of business. So those you do have to know. On the next test I will have some that involve those, and you have to know those. I don't think on this last test I had anything using those. But it's pretty simple, and we've already basically taken the next step. In terms of one more identity. So sine of a plus b. And how do you remember this? Kind of try to give you guys a way to...
Sine A cosine
Sine
B.
is the nice guy. Right? He says, all right, I'll give us both sine A, cosine B, and I'll be the same. And then I just kind of, each angle gets a turn there, right, with each of us.
Yeah. Yeah.
It's very out of context kind of big. So if I have A plus A instead of just A plus B, if I have two angles that are the same, which essentially is sine of 2A.
Right.
Sine of 2A, sine of A plus A. I can use the same formula again. But now I get sine A cosine A plus sine A cosine A. It's just 2 sine A cosine A. Nothing amazing. And I had a bonus question that used that.
Yeah, I saw that. It's a slide. I know what this is supposed to be.
And then the same thing for cosine A plus B. What was that? What would that be?
Cosine.
Yeah, cosine is the jackass, right? Says I come first. You want a plus, screw you.
Yeah.
Where's that at? It's just the same reason.
So if I do the same thing, if I put in there A plus A, so I essentially get cosine of 2A. I'll get cosine A, so cosine squared A minus sine squared A. This one's a little bit freaky, but you really only have to memorize one. This is another one of those, you can cut your memorizations in third because there aren't 3 things to memorize. Here's just one. On top of this, cosine squared is, what's the most basic identity involving cosine squared? Don't say x over h.
Minus 1.
Yeah, 1 minus sine squared.
1 minus sine squared.
So 1 minus sine squared is 1 minus 2 sine squared. Or sine squared is 1 minus cosine squared. Cosine squared minus 1 minus cosine squared will become 2 cosine squared. Minus 1. So if you try to memorize it, if I try to memorize this, I'll forget which one's first and all kind of shit. Where I just go, I memorize that. And then it's like 3 seconds to get there if I need it. You guys semi with me? So one of the most basic uses of this idea is if I have, for example, cosine, well, let's say I have, let's actually get ahead a little bit. Let's say somebody says, what's sine squared of, what's that? 15. If I say, what's sine squared of 15, you can't use your calculator. Obviously, I have not done that to you before today. That would be kind of evil. But you'll notice 1 minus twice sine squared is related to cosine 2a. And cosine of twice 15 is cosine of 30. And I have cosine 30. So I'd say, okay, cosine 30 would be 1 minus twice sine squared of 15. So then I can solve for what I need.
So you knew that you would use the cosine of 2a because you know that relates to the question.
Exactly. I have a question, and actually I'm kind of leading us into another way to write the same exact formula. They call this one the double angle formula because there's twice an angle in there. Then we have the half angle formulas, which are actually just the same damn thing, rewritten, solved for, like sine A. How are we doing so far? So what would we get here? We try to solve for sine squared.
1 divided by 2.
Subtract that, divided by 2, so I get 1 minus cosine 30 divided by 2. And I've done exactly this question based on a test before. What's cosine of 30? Yeah. 1 minus root 3 over 2. And again, I just do the trick, multiply top and bottom by 2. So I end up with 2 minus root 3 over 4, and I can basically stop there. You guys see that? Neato. So we have this, They call the double angle formulas. That's, kind of like, well, duh. These end up being more useful in calculus, or even here if I want to break this up so that I can, if I have other stuff that's involving just A, not 2A, except for one stupid thing, I can take that one stupid thing and rewrite them, and maybe so I can do something further. So on that example on the test, this is bonus, so I can do it now. I had sine 2x over 2 sine squared x. And I wanted to show that it equals cotangent x. Well, now sine 2x is... And what tells me to do that is I only have one thing double angle. Everything else has got non-double angle, right? Just the angle by itself. So I want to rewrite this.
Sine of x plus x.
Yeah, so this will be 2 sine x cosine x. The 2's go away. One of the sines go away. Cosine over sine is cotangent. One step. But if you noticed earlier, I was trying to come up with an example. There's not really a good example of, take an angle that we know. We know 30 degrees. Well, twice 30 is 60. Well, I know 60 also. Right? You guys kind of see what I'm saying? Sort of. I can't really come up with a good example like this for here, because why was this good? Because I don't know 15. And working it back, I can double it, and then I know 30. I know 30 degrees. But give me something and double it. Do you not know? If you know 60, you know 120, because you can get the reference angle of 60. There's no real good problem like this to make for that direction. If you have no idea what I just said, it's okay. Just telling you I can't make a problem like that. I can make a problem like this. But this is where it's more useful when I'm trying to simplify things. I can rewrite it. So let's take a second to look at this here. If I took, if you take, for example, the second one. Put the X in here. We basically just did this, but go one step further. Solve for sine. So if you solve for sine, I'm going to switch these two. Divide by 2. Take a square root. When I take a square root, I better put what? Plus or minus. And of course, that plus or minus makes complete sense, because it depends on which quadrant I'm actually in. Then I got to pick which one makes sense. So the math just says here, it could be one of these two. You figure out which one it is. Okay. So if you look on page 510, I really want to make sure you understand this. The ones on page 508 are the really nice ones, the one like this one and the one with the sine, 2a and all that. That's easy, that's nice. That's the same formula as this, isn't it? These are the same formulas here. And before I square rooted, that's, so look at the top of page 508. What do you see?
Normal angle formula.
I'm sorry, 510. Top of page 510.
Lowering the power.
I know, and they make it sound like it's something brand new. Formulas for lowering powers. But if I did not take a square root, wouldn't I just have sine squared x equals 1 minus cosine 2x over 2?
Yeah.
And that's exactly what they have there. I mean, so it's one thing I really don't like about books nowadays is if you look at them too quickly as a student, you'll feel like, holy crap, how am I going to memorize, I just had to know this. And then I can rearrange it to have anything else I want. I would so not memorize. In fact, I don't. If I had to come up with this directly, it will take me like 10 seconds, maybe a little longer than somebody has it memorized, but at least I have more space for something else. I can figure it out. I can do that. I need space. I don't want to memorize all this crap. Okay. If you don't agree with me, if you're born with like double the memory capacity of a normal person, great. You memorize it. Photographic memory, right? That's awesome. I am not that. You can do the same thing here with cosine. Cosine will be basically the same formula, except it'll be a plus here. Because this is cosine squared minus 1. Here, you guys take a second and solve this. Just solve that for cosine squared. It's 2 steps. Solve it for cosine squared. Of course, you add 1 and divide by 2, and that's on the top of page 510. And if you want at the bottom of page 510, you take the square root. So I really hate that they give each one its own name, because they're all the same formula. It's just rewritten. Maybe.
These are half angle formula.
So you'll see those, the double angle identities here, half angle identities there. I don't think I even put the power lowering, did I? That's just a freaky middle step, who cares? Okay.
So the half angle down here at the bottom, that's after you take the square root of both sides.
Yes, exactly. That's all it is. I love it. Okay. And these other ones, to be honest, I'm not sure if I even want to. Well, we could. Let's do this.
These are ugly.
Probably.
All right. All right, somebody help me out real quick. What's this top one going to be?
Sine x cosine y
Cosine y
plus
Good.
cosine y cosine x.
Who's kind of students out there going, just in case I turn around. And then this guy, the only difference really would be
Minus.
Yeah, minus. Now what do you get if you add those together? This side I get sine x plus y plus sine x minus y. Right, that's amazing. Yeah, equals 2 sine x cosine y. So then you get these, and then you divide by 2, and you get these. I desperately want you. I've got two kind of perspectives on this going on at the same time. These are important, but at the same time, it really is just playing around with a given formula, right? How many of you guys have taken stats? I know at least one of you. All right, shoot. Let's say. A lot of times you'll have a formula. Let's say I have this formula here. Those of you who have taken stats, you know what that is. Especially if you're with me, you know that. And I mean, this would be good. This would be a great formula, the way it's written. If I knew x, and I knew this, which is called mu, it's a Greek letter, but it sounds like a French count, over sigma. Right? These are just variables, who cares? So if I knew these three things, this is a beautiful formula. But what if I didn't know him? So of course, that's why we have algebra. We learn how to manipulate letters, and everybody freaks out. There's no numbers, and then we get over that. And then we have not really a new equation, just a reformulation of the old one. But why would I start here? Of course I'm going to start here if I don't know x and I know everything else. There's just less work to do. I've done the work already once, an infinite amount of work once. There's an infinite number of problems I could use this for.
Well, and like the d equals rt. The d equals rt, the distance equals time.
Yeah, okay. D equals rt. It's good if I know r and t, but if I want to know r, then I can take divided by t. Yeah, same kind of idea. So, I mean, these are really good for that idea. If I had the product, divide by 2 here, and they write it like this for some reason, you make it seem all extra amazing. If I had a product of two functions, I can redo it like this. So I have, for example, if I had sine of, oh, what do you got, Jeff? I don't know, dude. Sine of 15, cosine of 15. And I wanted you to do that without using a calculator. Anyway. This would be 1/2 sine of 30 plus sine of 0. You know, and then I could figure that out. So again, it's all about how to rewrite a given problem in terms of angles, trig functions of angles that you know. But even beyond that, this course is called pre-calculus for a reason, of course, because I know not everybody's going in, but that's the function of this course. And you have to understand how identities exist that will help you rewrite something from an ugly form into a much nicer form. And in calculus, you're going to learn a whole new reason for things to have different forms. Calculus is really easy if it looks like that, and really horrible if it looks like that. So I hope to God there's a way to take it over there, right? And the more of these you know exist, maybe not memorize, but at least know exist, you can look them up and rewrite something. It makes it much easier. That's really the purpose of this. To me, is just to make you realize you can play with an equation, make it look different, and it might be easier to do something with somewhere else. At this level, it's more, it's not quite as immediately useful for us, but that's the purpose of this class. It's just to get us used to this idea. Okay, maybe. All right. So section 7.3 is chock-a-block full of the stuff that you do not need to memorize. So those problems are really just going to be plug and chug kind of problems. You kind of with me? All right. On a test, I have been known to do problems like using the things you're supposed to have memorized, prove this. Right? And then you have to kind of do something like I just did. And it's just me testing to see if you got what I just said. You got to get used to this idea of just playing. And this is what you did algebra for, but now we're doing algebra with these trig functions. It's the same idea of just manipulating and playing with the letters and the operations. Okay. I appreciate those of you humoring me. Those of you like, when is he going to, is he done with this rant? All right. Yes, I am done with that rant. Let me see. Let's do a couple of problems out of here. If you have this sheet, it might be a good idea to have it sit next to you. You can just flip back if you need to look something up. On page 514. Try these problems out. 7. What Jeff? 32. And something you should have expected, starting at number 73, is this section's prove the identity problems. So now you have a much larger selection of things to try, which means they have a much larger selection of things to create things using, right? So that section, admittedly, that section becomes harder because now you have a lot more things to kind of try. So we'll try one of those out together here in a minute. We'll try these 3 out for right now. Oh. Oh, this here.
So, cosine 2.
Anybody else need a copy of that there? There we go. That's a back diagonal of that, yep. Everybody else?
Find sine of x first. And we have sine of x. And the sine is negative. Oh, here, but it's sine x plus 1. So it's
real quick, 32 should be really nice. I mean, right next to it. But, so cosine squared theta over 2 minus sine squared theta over 2 should be cosine twice theta over 2. And just cosine of theta. Cool. Same kind of thing here. 2 sine x cosine x is sine double x. 2 sine theta over 2 cosine there's sine twice theta over 2, so just sine theta. Again, there's just a certain level of getting used to these things. You need to get to a point, and this is why I assign the homework that I do, get to a point where this is just a little more immediate. Right now, obviously, for a lot of us, we're just seeing this for the first time, just using it for the first time. But you want them to be a little bit more on the tip of your brains. It's right there. Number 7, and this kind of problem that I kind of write down what each thing they're asking me for requires, and then I figure out how to get what it needs.
Is number 32b 2 sine, or sine 2 angle? Sine 2 theta?
Yeah, it'll be sine twice theta over 2.
Oh.
Yeah, sine twice whatever this angle is. Cool. So that's a good point. How would you rewrite this? The sine of 2x is twice sine x cosine x. Sine of 4x is 4. I like that, so that's wrong. That's understandable. The format does not care what's in here. The format says sine of twice something is 2 sine that thing, cosine that thing. So sine of 4x is twice 2x. So that's going to be 2 sine 2x cosine 2x. That's the pattern. That 2 is there just because there were 2 terms in the addition formula that we put together. So just because there's a 4 there aren't going to be more terms all of a sudden. It's still just 2 terms. Now here you can even break those up further and go insane, but let's not do that yet. Save insanity for later. So what do we still need to be able to do sine 2x? I know sine x. Just know cosine, and this is a nice triangle here, hopefully. Yeah. So which side's 3? I like that. So 3, 4, 5. I don't forever. If you want to put negatives on your triangle, you can. I just never really do. But if it keeps you straight, you can. Just be sure you put the negatives in the right place. Basically, that's never negative. Right, it's one way to keep it straight. Yes,
The only reason why they're negative is because...
Which quadrant?
Right. Yeah,
exactly.
quadrant.
So I'm doing like that reference triangle.
Right.
And the negatives I put in.
Sure.
If I know which one's negative, which is positive, yeah. Pythagorean Theorem, but it's also, hopefully you start to pick up the 3, 4, 5 triangle has come up a couple times. There's also a 5, 12, 13. There's also a 7, 24, 25. There's also millions more. So they're called Pythagorean Triplets. Sometimes they're called, not Euler triplets. Pythagorean Triplets will get you there. Nice integer sides of triangles. That doesn't happen very often, as you can tell from your tests and quizzes. Normally you get an ugly radical side. So this is kind of nice. So cosine would be what? We're in quadrant 3.
Negative 4/5.
Good. Negative 4/5. And just because what's tangent x?
Is 3/4.
Positive 3/4. I love it. Okay, so now I can basically do all of those. And of course, you got 3 options here. I just wrote down the one that I have memorized. So sine 2x would be twice sine x.
2 sine negative 3/5.
Cosine x.
Negative 4/5.
Because sine x is negative 3/5.
Oh.
You with me? The sine isn't still there. Sine applied to x makes negative 3/5. So the sine's gone. It's done its job. I'm kind of glad you said that because it happens a lot. I always see that sign somehow staying alive. Sorry. I started doing my in my head. Yeah.
The inverse of it, to find x, and then use that.
Oh, to find the angle. Sort of. But they're going to want, and I'm going to want an exact answer, not some decimal answer yet.
No, I didn't.
But I'll say using identities. How's that? So what do you get here? You get 24 25ths. Cool. 2 negatives cancel. And then here, if you want to use this one, or you could use this one, or whatever one you want to use. So if you use this one, you got 1 minus twice
11 fifths.
negative 3/5 squared. You guys still with me? As with me as you were? Is that a better way to say it?
I'm there.
So 1 minus twice 9 25ths. So 1 minus 18 25ths, 7 25ths. Now,
Negative or positive?
Positive. Positive.
7 over 25?
It's positive.
And the last step.
It's
now
positive.
here's the neat thing. If I'm in quadrant 3, real quick, if I'm in quadrant 3, and you don't have to do all this for this problem, by the way. Those formulas are set up to give you the correct sign, S-I-G-N. But if I'm in quadrant 3, between what two angles am I sitting?
180.
Yeah, 180 and 270. Now what's twice? So what's twice x going to be sitting in between?
360
Yeah, 360.
and twice 270.
540.
540, right? Which is basically from 360, 540 is 180 later. So I'm up there. What is, where am I at?
5 point.
2x.
7 over 25.
I get 18 25, 7 over 25, that's right. And I could be either here or here, right? And depending on which one I'm at, I'm either positive x or negative x. But the nice thing is the formulas will give you the correct sign based on where you are. And in fact, where you are really kind of depends on how long, y is and how long, so forth. So this formula, if you did it a different way, we should still get the same answer. There's no plus or minus radical where we have to make a decision. Are you guys semi over here? Maybe. And you can also see the 7, 24, 25 triangle coming out of here. I mean, if sine of 2x is 24 25ths, I could actually set up a little triangle right there. 24 25ths. This would have to be 7. So that's why cosine is 7 25ths. And now tangent's easy.
It's
24 over 7. Is that what we get doing this? Let's see, twice tangent was 3/4 over 1 minus 3/4 squared. Oh boy. So I get 6/4, I get 3/2 over 7/16. So I get 24 seconds.
I see.
So two things that came out of that's really nice. These formulas, the way they are, if they don't have a plus or minus in them, we do not have to pick based on where I am. They're actually set up to give me the correct sign based on where I am. It's only the ones that have the plus or minus in them that we have to choose. And that's when we take those square roots. I have to choose. I have to know where I am and tell which one it is, positive or negative. Okay. Alright. So this one we already did. What about this weird ass dude? And I kind of try to help us out a little bit. We have an angle right here. Remember, an inverse trig, physically that's an angle. The output in inverse trig is the input of a trig, and the input of a trig is an angle. So this is an angle, and I just gave it the name theta just so I can kind of look at it a little better. So this is theta over 2, and that's equal to this. And now I just got to plug in there what that is. 1 minus cosine of, what's the angle?
Cosine.
Yeah, inverse cosine x. And that's beautiful. Do I have to draw a triangle and all that kind of business? What's the cosine of the inverse cosine of x?
1.
Careful. X, because the cosine and the inverse cosine cancel each other. So you get plus or minus root of 1 minus x over 2. And I was trying to tell, they didn't really give any clues as to where this guy is, I don't think. So I can't even tell if it's supposed to be plus or minus. So that's as far as I can go. You guys want to take a break? Oh yeah, you need a break so bad you can't even answer the question. So come back at 5 after.